morning, how are you? The man you have been talking with, that is Mr. Denito. I'll be handling you physics online. So physics is a very simple subject. All you need to do is to be calm, learn to practice, and your knowledge of mathematics must be a bit beyond average. But let me see what we can do, and let's see how far we can go since you have an exam in a month's time. We'll do more of revision. I'm going to be posting short videos, after which we have our discussion, maybe on WhatsApp or any other platform we want to use later. To start with, we want to start with motion. Motion. We're looking at motion. We concentrate more on the linear motion, at least for the next let's say next a week. Then this teaching will go beyond here. We're going to be having discussion, and if you have any challenge as you prepare for your exam, feel free to talk to me, feel free to chat me up anytime. We'll keep discussing it. So it's going to be flexible. Apart from this normal video, you watch videos, and feel free to interact with me at any time so that you can keep learning even far beyond this scheduled time. So no problem. So we are starting with motion. So basically we are going to look at it. There are other types of motion we are going to be considering, but for now we start with linear motion, because we still have we have the linear motion which we are going to consider now. We are going to talk about circular motion. We look at the theoretical part and the calculation aspect of it. We have the projectile motion. We'll talk about projectile motion and simple harmonic motion. This has covered SS1 and SS2 topic. Simple harmonic motion. We're going to do it together since you are preparing for exam. Simple harmonic motion. We'll consider that. Simple harmonic motion. For now, we'll start with linear motion. Before we go into that, let's look at the definition of motion. Look at the types of motion. Definition. Look at definition. Look at the types. This is the definition of motion. Types of motion. Look at the terms used in describing motion. Then we'll go to calculation. Terms used in describing motion. Describing motion, and we look at the velocity time graph and the graphs, the velocity and distance time graphs, then the calculations aspect of it. We can consider the calculation and then the graphs. So that calculation will help. Also, when we are dealing with graphs, we also deal with calculation. Let's arrange it like that. Look at the graphs. Those are stuff we're going to, for the next 1 week, let's see how far we can go with this. Let's see, look at the definition, the types of motion for this morning, terms used in describing motion. If you get it very fast, can quickly move on as fast as possible. Everything depends on you. So let's move on. We start with definition of motion. What is motion? When do we say motion takes place? What is motion? Motion takes place when a body moves from one point, this is you, when a body moves from point A to point B. Motion takes place. When a body moves from point A to point B, motion takes place. Motion doesn't just occur. Something is always responsible for motion, and that's the concept of force, very, very important. It's always responsible for motion. Always responsible for motion. But we're not going to go into that. So coming back to that later. So motion can be divided as what? Since everything happens per time, motion can be divided as what? Time dependent. Time dependent change in position of a body. That is what? Time dependent. Time dependent change in position of a body. Time dependent change in position of a body. Time dependent change in position of a body, or simply says motion takes place when a body moves from one point to another. When a body moves from one point to another. When a body moves from one point to another. When it changes position. Moving from one point to another is to change position. When it moves from one point to another. We have different types of motion. We have 4 major types of motion we're going to be considering. After the video, we can now chat. If you have any challenge, we look at it. If there's no challenge, I'll ask you a few questions. Then go back to the second videos. We move on like that. Let's look at types of motion. I want to believe you've gotten this. Motion is time dependent change in position of the body. When the body moves from one point to another, motion has taken place. Motion has taken place. So we have going to what we call the types of motion. Types of motion. Types of motion. Types of motion. We have types of motion. Okay, let me write it here. Types of motion, very fast. This is just very simple. We gradually move on to get to aspect that will require more and more explanation. All this is very, very important. I can easily pick your book and read this. We have types of motion. Types of motion. We have one. We have translational motion. We have translational motion. We have random motion. We have random motion. We have oscillatory motion. And we have rotational motion. Rotational motion. This is the major. These are the major types of motion that we have: translational motion, random motion, oscillatory motion, and rotational motion. What does that by translational motion? Translational motion. We translate. Translational motion. Translational motion can be divided as what? As when a body moves from one point to another. When a whole body moves from one point to another without rotation. That is, when a body moves always on a straight line, always on a straight path. I can draw a straight path to describe it. That's the most common type of motion that happens every day. When the whole body moves from one point to another. Translational motion takes place when a whole body, or movement of a whole body, when a whole body moves from one point to another, from one point to another without rotation, without coming back to the starting point again, without rotation. If it has to come back to the starting point again, that's not translational motion. That's movement of the whole body from one point to another without rotation. It's always a movement along a straight line. A car moves. Example, a car. Let me draw it like those babies' car. A car moves from point A, from Lagos to Ibadan. Move from Lagos to Ibadan. A car move from Lagos to Ibadan. That's a simple example of from Lagos to Ibadan. That's a simple example of what? From a car move from Lagos to Ibadan. That's a simple example of translational motion. Doesn't have to pass through Lagos again. No. That's just always along a straight path. Your movements from your bedroom to your sitting room is a form of translational motion. Movement from your room to your bedroom, and movement from your bedroom, that is translational motion. That's simple, very simple. From one point A to point B, we're going to what we call random motion. Let's consider random motion. Let me pick it one by one now. Random motion. Some people call it zigzag motion. Use the word zigzag. Have you ever observed a butterfly? Butterfly moves here and there. Moves here and there. Exactly. That's zigzag motion. Irregular motion of the body without a specific direction. Call it what? Irregular motion. Random motion is an irregular motion of an object or of a body without a specific direction. Without a specific direction. Regular movement of an object without a specific direction. Irregular motion of an object. Or let me call it irregular movement of an object without specific direction. Movement of an object without a specific direction. Some call it zigzag. The common example of random motion is Brownian motion. I've heard about Brownian motion. Exactly. Motion of what? Particles, suspended particles of gas, air molecules. So we have the common example is Brownian motion. Common example, e.g., that's Brownian motion, which you have heard about. Yeah, it's a common example of random motion. Exactly. That is what? Motion of what? Particles suspended in air. Particles suspended in air. Water molecules. We have the water molecules, the movement of water molecules, exactly, and even the gas molecules. Those particles, they move here and there. Exactly. Those are common examples of Brownian motion, which is an example of random motion. All these are very, very simple. These are very, very simple. Look at the third one. Look at oscillatory motion. Feel free, go through the video. If you have any questions, if you don't have questions, I'll keep asking you questions. I have a lot of questions to ask. We'll keep asking questions, and over time we get to use past questions. So let's consider the third one. Let's consider motion. Consider oscillatory motion. Let's consider oscillatory motion. Oscillatory motion. You hear to and fro. You have ever seen in your lab where you have your little stand? You have your little stand, and you have your pendulum bulb suspended. As you close it, push it to and fro about the mean position. To and fro. We call it to and fro movement. To and fro. That's a common example of oscillatory motion. To and fro movement of objects about a mean position or equilibrium position. You close it here, it goes to and fro. To and fro. That is to and fro movement of an object about a mean position or equilibrium position. A common example is that of pendulum bulb. This is a pendulum bulb, suspended pendulum bulb. Pendulum bulb. Suspended pendulum bulb. When you suspend it here, allow it to flow, move to and fro. That's the common example of oscillatory motion. Any vibrating bodies undergoes oscillatory motion. Is what? Is the to and fro movement of an object about a mean position or equilibrium position. About a mean or equilibrium position. Or equilibrium position. A mean or equilibrium position. To and fro movement of an object about a mean or equilibrium position. Any vibrating bodies. That's a common example of any vibrating bodies undergoes this. Pendulum bulb is an example. Any vibrating bodies undergo what we call what? Oscillatory motion. Oscillatory motion. So very, very important to note that. Very, very important. Then we have other examples. Also in your lab, suspended spiral spring. Also, when you suspend your spiral spring, the spiral spring also can be suspended. When you suspend your spiral spring, you know your spiral spring now. Okay. And you put the mass suspended using the spiral spring. Use your mass or your weight. Let's say 20 grams mass. When you suspend it and you display it that way, it goes to and fro, up and down, without mean or equilibrium position. And that's a common example. Apart from this, that's a common example of, so suspended spiral spring. Suspended spiral spring. When suspended, the weight on it goes up and down, up and down, up and down. Also, we have when you put a test tube, also you put in a liquid, your test tube loaded with maybe iron filings or put sand on it. That way it goes to and fro. Okay, you do it in such a way that that movement is also test tube. Okay, so look at it very well. Loaded test tube. You have a loaded test tube. Loaded test tube. This is also common. We have seen this times without number. All these are common examples of auxiliary motion. We have this, we have this, we have this. These common examples of auxiliary motion. That's last but not the least for this video. I would like to ask a few questions and I'll try to explain myself any area that is not clear enough before we go into the other aspect, times use, then go into the calculation aspect of it. We have the last aspect of that is rotational motion. Rotational motion. That is rotational motion. This is more of a revision. But let's get yourself refreshed on this. We have rotational motion. The fourth one, we have rotational motion. This will be the end of the first video. We have discussion after now. Then I'll post the second video. Rotational motion. Rotational motion. Rotational motion. That's the motion of the body along a circular path. Is the motion of a body along a circular path. Along a circular path. Motion of the body along a circular path. That's so easy. A common example, this is common. The blade of your fan. The moving fan. Fan blade. You know that. Okay. The blade of your fan goes. Okay. From the blade of your fan. The fan blade undergoes circular motion. It moves along the axis. Fan blade. That's a common example. Fan blade is a common example. We have earth rotation. Out of earth rotation, you learn that in geography. Earth rotates on its axis. It causes day and night. It takes 24 hours for Earth to rotate on its axis. Earth rotation. Rotation of the Earth. Earth rotation. It rotates on its axis. Earth rotation. Earth rotation. Earth rotates on its axis. Earth rotation. Very, 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 very important. Very, very important that you take note of. We have those are the common. There are other, other examples that we look into. So now we go into. So far we have talked about definition of motion and types of motion with their examples. You must have this on your fingertips. Nothing really serious. Yeah. We go to terms using describing motion. We have to talk about velocity, acceleration, things like that. That will be during the second. Let's have a brief discussion on this, and if there's nothing, we can move on. Then before